Okay, so I want to talk a little bit more about some other indeterminate forms, in particular the multiplication form 0 times positive negative infinity. Before we do that, let's just do a quick reminder of L'Hopital's rule and how we use it. So if I have something like the limit as x approaches 0, sine of x minus x over 12x cubed minus 9x, I can't use direct substitution. When I directly substitute, I get sine of 0, which is 0, minus 0. It gives me 0 on top, all over 0 minus 0, which is 0. This is an indeterminate form. It's an indeterminate form to which we can directly apply L'Hopital's rule. L'Hopital's rule says, when I have an indeterminate form of the form 0 over 0 or infinity over infinity, I can take the derivative of the top. The derivative of sine is cosine. The derivative of negative x is 1, all over the derivative of the bottom, 36x squared minus 9, and these limits will be equal. Okay, so now let's see what happens when we plug in 0. When we plug in 0 in this case, cosine of 0 is 1, so I get 1 minus 1, which is 0, over, on the bottom, 36 times 0 squared is 0, minus 9 is negative 9. Notice this is not an indeterminate form. We have 0 divided by negative 9, which is simply 0. So thus, this original limit as x approaches 0, sine of x minus x over 12x cubed minus 9x is 0. Let's look at another example. Here is the limit as x approaches e of 1 minus natural log of x over e minus x. Well, when x approaches e, outline of e is 1. So I have 1 minus 1, 0, over e minus e, which is 0. So I'm again in position to use L'Hopital's rule directly. I have the indeterminate form 0 times 0. Applying L'Hopital's rule means I take the derivative of the top. Derivative of 1 is 0. Derivative of natural log of x is 1 over x. So that's going to give me, on top, negative 1 over x. I still have that negative sign. All over, on the bottom, the derivative of e is just a number, is 0, minus x. The derivative of negative x is negative 1. Now I can plug in directly e to get negative 1 over e divided by negative 1. The negatives cancel, just leaving me with an answer of 1 over e. Okay, so 2 examples of directly applying L'Hopital's rule because we have that indeterminate form. Remember, sometimes we have to apply L'Hopital's rule more than once because we get an indeterminate form and then another indeterminate form, etc. Okay, now let's look at some of our indeterminate forms where L'Hopital's rule doesn't directly apply, but we can do a little bit of rewriting. In particular, we're looking at the form 0 times positive negative infinity. So that might look something like this. Limit. Okay, so now we're going to talk about indeterminate form, 0 times positive negative infinity. So let's look at the limit as x approaches 0 of, let's say, x times ln of x. Now first we need to make sure that we have the right form. Well, as x approaches 0, x certainly approaches 0, times natural log of x as x approaches 0 approaches negative infinity. So we definitely have the right form. So again, we can't directly apply L'Hopital's rule, but what we can do is a little bit of a rewrite. So I'm going to take this, that x times natural log of x, and I'm going to do some rewriting on it simply by essentially moving one of these terms into the denominator. Now I could technically move either term into the denominator, but I want to pick the term that's a little bit simpler. In this case, x is my simpler term. I'm going to move it into the denominator. When it moves into the denominator, I have to give it that negative exponent. So this, x, natural log of x, is the same thing as natural log of x over x to the negative 1. So I'm just going to rewrite that limit. Notice I haven't done any type of calculus, L'Hopital's rule. All I've done is algebra. And the algebra says rewrite this limit x ln of x as ln of x over x to the negative 1. Now let's look at the form that we have. Well, as x approaches 0, this goes to negative infinity. As x approaches 0, this x to the negative 1 is really 1 over x. But as x approaches 0, that approaches infinity. So we've changed this from the form 0 times infinity to infinity over infinity. But infinity over infinity is one of our indeterminate forms to which we can apply L'Hopital's rule. So now I'm going to apply L'Hopital's rule. L'Hopital's rule says we're going to take the derivative of the numerator. The derivative of the numerator is 1 over x, all over the derivative of the denominator, which is negative 1x to the negative 2. Now the question here is, have we actually gained anything? So to answer that, let's do a little simplification on what we've got going over there. Okay, so inside our argument, we have 1 over x over negative 1 times x to the negative 2, which I could write as negative 1 over x squared. Okay, now there's lots of ways to simplify this. If you're having trouble seeing how to simplify this, rewrite this using division. This says 1 over x divided by negative 1 over x squared. So this also says 1 over x divided by negative 1 over x squared. But when we divide fractions, we multiply by the reciprocal. And now look, we get some cancellation. So I'm left with just 1x in the numerator with a negative, or just negative x. So the limit as x approaches 0, 1 over x divided by negative x to the negative 2 is the same thing as the limit as x approaches 0 of negative x. But now we can just directly substitute and see, hey, that's 0. So we can take a form that's not ready for L'Hopital's rule. Remember, L'Hopital's rule only applies to 0 over 0, infinity over infinity. But if we have something like 0 times infinity, we can always play this trick where I take one of my functions, move it to the denominator, and that's going to change it from the indeterminate form 0 times infinity to 0 over 0 or infinity over infinity. Once we're there, we can directly apply L'Hopital's rule.